Welcome to the ArduPilot Developers Conference 2025, organised by KH Unmanned, hosted by 3DXR in North Yorkshire. With thanks to our sponsors, 3DXR, Aerosystems West, CUAV, QPilot, High-Tech, Holybro, IR-Lock, KH Unmanned, Kraus Hamdani Aerospace, Maytech, Modal AI, Northwest Blue, SD Model and Theseus.
Wait. What about FOSS-UAV? Right, maybe a bit early to sponsor a conference, but yeah, FOSS-UAV, that's my new endeavour. Well, an old endeavour, it's been going about 3 years, but now I'm going to be doing FOSS-UAV full time. So hopefully lots of software development, making the software better, making ArduPilot even greater, and then quite a lot of drone tuning. Got a light show drone I'm going to tune this morning. It's very calm and still, as you can see, so ideal conditions for tuning. But yeah, so if you have software requirements or tuning requirements, please get in touch. I'm a little busy at the moment, which is great, but yeah, and even I'm hoping in this demo, in this talk, I'm even hoping to sell some of these drones. So if you're interested in buying or participating in those, yeah, let me know. Exciting times, as they say. Anyway, enjoy the video, enjoy my talk, enjoy the demo. Thanks for watching.
Next talk, Acro-Fencing, AI and Acrobatics with small, fast drones. Over to you, Andy Piper.
Thanks, Matt. All right, let's have some fun. So, this is 4 talks in one. So rather than getting into loads of technical details, I'm going to show a bunch of PRs, do a bunch of interleave demos. There might be time for questions at the end, but I doubt it. So please come up and bother me afterwards, and I can talk through. My demos and my talk just got more and more ambitious, and I thought, okay, I'll just demo stuff, and hopefully you'll enjoy it. And then I've got a real demo after lunch. Okay, quick little bit about me. My background is in software, mainly enterprise software. Been contributing to ArduPilot for about 7 years now. I've got my own consulting company, which I've been running as a sort of side hustle for 3 years now. But now I'm doing ArduPilot full time. So if you want consulting, thank you. I do software consulting, but I've also tuned a lot of drones, a lot of light show drones, some of which you may have seen. So yeah, please get in contact by all means. All right, so what is the problem I'm trying to solve here? Let's go this way. The picture's supposed to appear afterwards. So what I wanted to do was fly acro safely in a natural way. So acro's kind of hard. And so my basic premise was construct a tin can fence, fly acro inside the tin can fence, and then at the fence, normally with a fence, either you get told something bad happened and you crash, or you switch to RTL or land or something like that. What I wanted to do was bounce off the inside of the fence and then hand control back to the pilot afterwards, and ideally not crash. So this is the picture Gemini gave me. I did actually pay Elon Musk for some Grok Imagine credits because I thought I could do some amazing videos for this, and they were all terrible. Really, really terrible. Worst purchase of my life. So, you know, don't use Grok Imagine, I would say. But this is kind of the idea. So what do we need to make this work? It's a simple thing in theory, but putting it all together is somewhat complicated. So first of all, this is all going to be done with Lua. So guided control using scripting, using Leonard's guided capabilities within Copter, driven by Lua. The next thing we need is obviously good fence support. There's been a bunch of fence support in ArduPilot in the past, but there's certain additional features that you want. In particular, you want a floor in your fencing because you don't want to crash into the ground. That's the sort of most, the lowest bar if you want, or the highest bar. And you want to have good fail-safes. So obviously you're trying to, or I'm trying to, provide a user experience, but at the same time it needs to be safe, so I need to have real fences as well as kind of my own virtual fences. Lots of testing, more testing. Prefer to crash things virtually than in the real world, which means a great simulation environment. And then also, when you get into the real world, you need to have quite a good real world environment as well. You want copters that are actually going to do what you tell them to do. Time. So I've been doing this for about a year, I want to say. This has become a little bit of a labor of love. Went down many, many, many rabbit holes, lots of patience required, and obviously a lot of propellers as well. Okay, so first up, guided control via scripting. And actually there's quite a good support for this currently in ArduPilot, and these are the sort of guided methods that are currently available. That's sort of a good start. So I was sort of onto a winner with that. Fencing. What about fencing? Well, I don't know whether, some people have seen this PR, so I thought, oh, I'll just add min-alt fencing to ArduCopter. Little did I realize the rabbit hole I would be diving into with that PR. And it doesn't actually show the number of changes here, but this PR went on for months and months and months and months. So I needed that fix. I then wanted fence margins, and we'll see this in the demo. So this is, so you want a solid fence, a fence that can't be breached, but you also want to give the copter time to do things. So you want a fence that's a little bit inside your solid fence, and you want to know about it. So this is fence margins, which is also merged. And then I found I needed to know where the margins were, which is not merged. I needed to record more margins. I didn't want to fall out of the sky. I also wanted copters to react very quickly to fences, so the fence code used to be at a relatively slow update rate, and of course things can happen quite quickly in copters. So I wanted those to be fast. And you know, more and more and more and more and more and more PRs. Whoops. Where did that go? Okay. All right, so let's do a demo. Oh. It's this one, right? I don't know what went wrong here. Okay, so in the corner here, you can see my real flight simulation environment. And that's what we've got running here. And so here is my copter. So this is a fence demo. And if you haven't seen fencing before, let's get rid of that. Try and get rid of that. This one, okay. And let's see if we can get some sound as well. Maybe. All right, so. Mustn't be an RTL. Bombing motors. Doesn't look like there is any sound. Up we go. All right. So I'm going to do this in, so we're in chase mode, so we can follow the copter. And you can see the little, so this is the little GCS output. And you'll see if we keep going up, up and up and up and up. Oh, the min-fence alt is enabled. And now if I try and go down, I can't. The copter stops. So this is with object avoidance. I don't know whether you know in loiter, if you've got object avoidance enabled, it will prevent you, it'll slow you up as you reach the fence and then stop you. And so this is stopping you land, which could be a problem, but we'll see about that. Now, I can also fly forward, and the same thing happens when I get to the edge of the circle fence. it slows. You can see the copter slowing up, and then eventually it stops, and I can't go any further. So this is sort of good fence support. And if I want to land, I can hit RTL, and this RTL is a little bit like my real copter, which you should see later today. And down I go. There we go. And I should have increased the landing velocity, so we didn't have to wait for it to land. All right, so what about margins? So this is, again, fencing, but with margins enabled. So this time, when I, oh no, gyro is inconsistent. Gyro is inconsistent. Pre-arm good. All right, up we go. Not in RTL, up we go again. Armed, okay. So this time I'm going to go up, up. Get above my margin, above my min-alt fence, so min-alt is now engaged. Okay, so now I'm going to fly forward. And what you see is now, you see the margin warning coming up there. And because I've got object avoidance going on, I can't get very close. It's like being on a rubber band. So I can sort of fly up fast to it, and then it gets slower and slower and slower, and you can see the margin sort of slowly stopping moving, and then the thing stops. And then if I try and go down, the same thing happens. So, oh, it doesn't let me go down, but it should tell me where the margin is. Nope, all right, we'll do RTL. Back we go again. All right, so that's margins, and while that is landing, we should go back to the presentation. No, that's very confusing. Back to the presentation this way. Okay, so fence margins. So the next thing you want, so you need good fence support. The next thing you want is good attitude control. So when you're flying FPV, you don't want to kind of, if you're turning, you don't want to go like this. You want the camera to stay around in the way that an FPV pilot would expect. Whereas the guided mode control optimizes the thrust vector, which might not be what an FPV pilot expects. So you need to control attitude and yaw, followed by velocity. And this is where the scripting APIs that we currently have are not quite what I need. And so I had to add some functionality to scripting, and in particular to control yaw as you're sort of gaining particular velocity. But then for some additional functionality, I wanted a function here that allows you to set target angle, rate, and throttle. So it basically gives you complete control over the attitude, velocity, acceleration of the vehicle in guided mode from scripting. So this was all well and good. I needed to do some testing. So I wrote an auto test, and I did some auto testing. And I was going to show an auto test demo, but sorry, Peter, not enough time, so on I move. So what I really wanted to do was testing in real flight. And this is why I've got this real flight computer here. Now, this again was a labor of love. So I started off with a semi-powerful computer and encountered all sorts of issues, which I was told were related to the power of the computer. It was a little bit more nuanced than that, but I upgraded the computer. That gave me some better performance, but there's still issues. So I'm going to show you one of the issues, if I can, in real flight. So we'll go back here. All right. So this is running on current master. I've called this Acro Trouble. You'll see why. Okay, and you can see on current master, we've got this sort of refresh rate of about 600 to 700 frames a second. And I am going to fly this in Acro, badly, in FPV mode. All right. So, okay, so this is a bit like what an FPV pilot would see in real flight. Okay, up we go. Should be in Acro. Yeah, we're in Acro. So we can fly around in Acro. We can do a roll. We can do a flip. But if I start pushing it a bit harder, okay, this is not me. I just pushed the throttle up, and this is what's going on. So what I found lots of things, but there are quite a lot of problems with real flight and the update rate in particular of real flight related to the physics of the copter. So let me just land that again. Here we go. Oh no, I don't seem to have RTL. Oh, crashed. Oh well. Oh, he bounced off the ground and now he's doing RTL. Very nice. I wish that happened in real life. Sorry? Yeah, need more props. All right, so back to my presentation here. So what I wrote was this new PR, which has enabled stable timing on real flight. So in fact, I did two things. So I created a new model. So the model you're seeing here is a Rise 255 with some ArduPilot extensions. So I added 3-blade props. I made it 6S. I gave it active braking. And it generally works relatively similar to the copter you'll see later. And it's supposed to be have proper thrust expo, but again, sort of real flight is good up to a point, and then the physics seems to start breaking down. And in particular, this deal about IMU timing. So what I discovered was that every time you do an update tick in ArduPilot, in Citadel, it essentially does a round trip with real flight. And that round trip is very, very jittery. Like the time can go up and down. And that plays absolute havoc with ArduPilot's control algorithms, essentially. So what I did was I basically made the virtual IMU run at a much higher rate so that I could get very, very stable IMU ticks. And I fit those ticks into the update frame that real flight gives me, because I'm sort of running on a fast computer. So what can happen is you get an update frame, and then basically you can do all of the frames within that period between that frame and the previous frame to make sure you get sort of stable IMU updates. And so if we switch back here, all right, so what's my branch called? RF Fast IMU, okay. So this time, what you'll see is, so if you remember, it was sort of 600 or 700 frames a second. So here it's like 5,000 frames a second. So I basically split it into sort of roughly 10 ticks per real flight frame. And this allows me to get much, much more stable IMU timing, which then means that the flight dynamics themselves are, okay, here we go again. No, in RTL again. I should know by now, right? Here we go, armed, up we go. Right, so I'm not going to push this too hard because I can probably break it again anyway. But basically what I found was this just gives much more stable, sort of locked-in feel. It's not perfect. It's not like a real copter, but it just is much, much, much more stable. And the other thing I did with Leonard's help was I ran System ID on the copter, and that allowed us to sort of notch out some of the weird gain characteristics of the model in real flight. So I really encourage you to try this. It's not yet merged because there's some issues with Sigwin, but hopefully we can get it merged at some point soon. All right, so, I'm too many computers. I'm making this mistake a lot, so I want to be on the other computer. All right, so here we are. So testing in real flight. So I had my good simulation environment. I had my good fences. We've seen some real flight demos. Then I wanted to move quickly. So in my day job, my past day job, I did a lot of stuff with AI. And got Autotest, got real flight, but I found the iteration rate of trying to make changes, particularly in Lua, which I'm not, my C++ or Java is my thing. Particularly in Lua, I found that quite slow for me. And so what I did was I started engaging Google Gemini, which is Google's LLM. And if you don't know anything about, I'm sure everybody knows something about LLMs, but there are good ways and bad ways to use LLMs. And the bad way is just to say, tell me the answer to this question, do this thing. You basically have to treat LLMs like 5-year-olds. You have to tell them the same thing 6 different ways so they don't get it wrong. But they're very, very capable 5-year-olds. They can do amazing things, but if you don't give them very tight constraints, they'll go off and do crazy things. And so the way we solved this at my previous job, and the way I've sort of solved this here, is using this notion of playbooks. So basically what you can do is you can write a document that says, you will do everything, when I ask you to do X, these are the constraints that apply to do X. So take a good example. You're writing Lua. If you write Lua code, you can only use APIs that are in docs.lua or core Lua. You can't make stuff up. You can't say, oh, I think if there was a guided mode function that did this, that would be the right thing. LLMs do that all the time. They hallucinate functionality all the time. And you can use playbooks to basically constrain that functionality really, really nicely. So I did one for Gemini, and I still haven't done a PR for this, but it is a public branch, so you can see what I've got there. And basically, I've got one for paired programming, so how do you write Lua in general? And then I've got one for vehicle control, so how do you control a vehicle and obey the rules. And the nice thing about this is that I can now write Lua using Gemini without any syntax errors, generally without logic errors. Usually it's a sort of interplay between myself and the LLM about very subtle things. It's not about how do I write Lua code to do this for loop sort of thing. All right, so let's try it. So what did I try first? So this was my detour from Acro-Fencing. And I thought, okay, I'll do some AI acrobatics. So I know Chappie in the last conference said, oh, if you could do some cool acrobatics all automatically, that would be quite nice. So I thought, okay, right, I'll try that using Gemini and using some of this updated scripting code. And so what I did is I developed a vehicle control library to do flips on a switch, which I will demo later. And what I wanted to do was make it a little bit more subtle than that. So basically, you could use a spring-loaded switch and flick it the number of flips that you wanted in a single sort of instance of the move. And so I used Gemini to do that. And let's have a look. Let's see how it did. All right, we'll switch back to... I think we'll go to fixed this time. All right, so this is going to be, so what the script does is I take off in loiter, the script, when it's engaged, switches to guided, does the maneuver, switches back to loiter, hands you back control. So you can see kind of why I did that given my end goal of Acro-Fencing. All right, it says pre-arm is good. Let's take off. Up we go. All right, we'll go a little bit higher. Not that I'm nervous about it working or anything. Hopefully you can see the copter there. Okay, so one flip. Up we go. Flip. down we come, and it breaks, and then it goes back to position. So this was all written, the whole thing was written using Google Gemini. So it wasn't my, it was some of my coding, but in the main it was written by an LLM with my input. Show you again, 2 flips. Up we go, 1, 2, back down we come, breaks, and then it moves back to position. And just, so I'll demo this on a real copter after lunch, but just so you sort of understand the physics of what's going on here, the idea is that we basically give high throttle input, and we want to reach a sort of escape velocity such that when the throttle is dropped, there is enough time to do the number of flips that you want before you fall back down to the same position, at which point we'll apply the same throttle input. And then hopefully that all works out and the copter's in the right position, but generally it's not, and then we'll use attitude control to sort of bring it back to where we want it to go. So I can do 3 if I want. Here we go. 1, 2, 3. Down it comes, brakes. And the only problem with this is what we discovered was the copter is quite floaty in real flight, so it turns out that the throttle setting is way too high at minimum in real flight, and I just didn't have enough time to retune it and all the rest of it. So switch back to RTL.
And you should add a direction of sticks or direction of flip.
Ah, yes. So the library itself does allow you to do roll or pitch, and I wanted to do exactly that, but time was not on my side. Okay. And I can probably just show you quickly in VS Code. So this is my playbook, and then you can see somewhere here I've got a module, got this vehicle control library, and it's pretty complicated. You know, we've got like 650 lines of Lua written by Gemini, and then I've got an applet flip on a switch here. Again, that's calling that library. Another, 344 lines. But the experience for me was amazing. Like, I could really just iterate through my vision of what I wanted to do rather than just getting caught up in the vagaries of sort of Lua syntax or anything like that. Okay, so AI acrobatics. So it worked pretty well. And so when I went back, I'd sort of developed my Acro-Fencing code up to that point, and then I got Gemini to review it. And Gemini said, yeah, it looks pretty good. I think that's good. So I was happy at that. Who believes in LLM these days? But it worked pretty well. And the nice thing about it was I was then able to use Gemini to add other features that I felt were necessary from a sort of safety and usability perspective, but which I was sort of running out of time. So I added a loitering at home feature, which we might see. I added an auto takeoff feature. I did a max alt failsafe, because I also discovered, as well as not wanting to crash, you can actually, if you've got the throttle too high, you can just take off to the moon and the thing doesn't come back. So, all right, so back to the actual aim of this, which was Acro-Fencing. So back to the demo. There we go. All right. So I'm going to do this in loiter just, well, save my piloting skills a little bit, but just to make it a little bit easier to show what's going on. This is an older version of the code that I didn't want to mess with, but I discovered some fairly significant issues with this in the testing earlier in this week, which I've sort of fixed in the real thing. But I didn't want to go back and redo all of my demos, so. Okay, so pre-arm good. So I'm going to enable Acro-Fencing. So you can see Acro-Fencing on there in the corner. And if I arm, arming mode, and then you can see it says raise throttle to take off. So I raise the throttle, and the thing shoots up into the sky. Let's do on chase. That's probably a bit easier. Okay. And then when I get to the right height, okay, so now I've immediately breached the min-alt fence. It stuck me back in guided. Let's reduce the throttle a bit, see whether I can come down a bit. Okay, 144, 133. Okay, so you can see it says pilot back in control now, so I can now fly this around. I can head towards the fence, try and keep my height decent. So this is a circle fence I'm flying in. And when I hit the circle fence, you can see it flip me around, gives me back control, it says pilot control, and back in it. So I'm now in control now, I can fly the thing. Oh, there I hit the min-out fence, so you see I bounced off the bottom. So I need a bit more throttle to keep me away from that, back in control. Oh, flips around because I hit the edge of the circle fence, I think. All right. So I am in control now, but you can see it's a little bit sketchy. All right, so bring it back for RTL. Yeah, it's a shame the sounds aren't working. My wife hates the sounds, but I feel it gives it a bit more realism. All right, I'll let it land. Very slowly. Okay, landed. Right, turn off Acro-Fencing, back into Acro, turn on Acro-Fencing. Right, so I'm going to try and fly this in Acro in chase mode, which I find a little bit, Please don't tell me how bad my piloting skills are, I know. Here we go. Raise throttle to take off. Okay, so we're going up. Right, okay, so I'm in Acro now, so I'm going to try and fly in Acro to the fence. I'm getting too high. Let's go down a bit. Oh, and there, it's flipped me back around, put me back in control, and I can fly again. I should be able to do flips still, yeah. Keeping the fence, should be able to go around, yeah. Now I'm really getting confused. But you get the idea. So, and before we crash, we'll hit RTL, go back to the presentation. Oops. Okay, so I did all of that virtually because I didn't want to crash copter after copter after copter. I then finally got to try it in real life. And it was pretty scary at first, I have to admit. It was, very scary. But it actually worked pretty well with some teething issues. I had one issue where the trim wasn't checked on takeoff. So I've got this like raised throttle to arm thing. And the function I was using didn't, I think it took trim into account, and I had trim set at the midpoint on throttle. So to get raised throttle to arm, I had to go past the midpoint, at which point the thing shot up into the air to about 100 meters. So I fixed that bug. The other thing I found was the messages, and they're in the OSD, they're not super obvious. You kind of want a bit better OSD integration so you can see what's going on. And the fence messages can get a bit spammy. But on the whole, it worked okay. So I've sort of called this small, fast drone, and my plan is to sort of progress this, maybe build some drones with this capability, sell a few of them, hand-built, hand-tuned, pre-configured. The issue is, of course, that it's quite dangerous doing the testing. I don't want to do this with some, I don't want people doing this with some enormous, well, I I suppose the Callisto might be capable, who knows? But you know, the vast majority of drones are going to struggle with the level of control that is required for this to work well. And particularly on an outer spec vehicle, you know, this relies on guided mode at high speed working really, really well. Your GPS needs to work really, really well. There are lots and lots of things that can go wrong. But has been quite successful for me. I plan to keep iterating, do more acrobatic moves, and see where I get to. Now, I'll take questions. My initial plan was to do Gemini with audience participation and see if we could write a Lua script using Gemini, but I think that's probably overly ambitious. So I have got a couple of minutes for presentations. So, questions, sir?
Yeah, I can confirm it does look scary when you were testing it earlier in the week. But no, so when you're bouncing between the fences, is there any chance it can like bounce basically between the two bounces, between the lower and the outer?
Yes. Yes, and in fact, the testing we did earlier, so the interesting story, which I've told to a bunch of people already, but there was a bug that I was chasing earlier in the week, which turned out to be Lua's. I was writing my own log file using Lua, and it turns out that the implementation of that, for whatever reason, is really, really bad. And so what was happening was I was hitting the margin fence, and then 5 seconds later, the script would wake up, notice, and flip me around. But by that time, I was way beyond the real fence. And it all came down to this issue with writing your own log file. So I switched to ArduPilot logging, and that completely fixed that issue. But the problem was, what happened was, it was bouncing outside the real fence, turning around, and then bouncing off the outside of the real fence, and then going off into the middle distance, and yeah, so a little bit dangerous. Pete said, whatever you do, don't fly over there, and the first thing that I did was fly over there because it bounced off the wrong fence. So yes, that can definitely happen. No more questions? Oh, Randy.
Yeah, really, really great. I was just wondering, like, about the decision to flip the vehicle around. I would have thought, you know, I'm not an FPV pilot, so maybe that's totally natural for an FPV pilot, but, you know, for the regular loiter fence, we just stop at the fence and wait there, or stop the user from, you know, traveling any further. Can you just tell me a little bit about, or tell us a little bit about why you decided to flip the vehicle around instead of stopping at the fence?
Because I wanted to, so the idea of this is to actually be able to fly in Acro. And so I wanted people to sort of just be able to blast around in Acro and not have to worry about where the fence was, essentially. So that was my way of saying this feels more natural than just stopping, but that's certainly possible, certainly possible.
I think one thing to bear in mind, Randy, is that often the camera angle's tilted way up on these, and so if you come to a stop, you can really lose situational awareness, especially if you start backing up too to get back into the fence. So, like whipping around keeps you seeing like
right.
the horizon level.
Yeah, you'll be looking up at the sky.
Yeah, so you don't suddenly, have to reorient yourself.
So I was curious from like a user, when you breach the fence and then it kicks control back to you, does it change your mode back out of guided, or what does that look like?
Yeah. So it saves, it records the mode you were in, it flips into guided, does the maneuver, and then flips you back to the mode you were in before when it hands back control.
Let's say you were doing a backflip into the fence and you hit the fence upside down. Does it flip you away from the fence and then leave you upside down, or how does it exit that maneuver?
Badly, probably. So a lot of the testing I did, I had to add all sorts of fail-safes, like if you don't achieve the attitude and velocity vector, give up RTL, go back. So one of the things, so a couple of the features I did, which actually we didn't see in the demo, but one is if you take your hands off the sticks, it will flip you into loiter and just park you there until you put your hands on the sticks again, at which point it'll flip you back into Acro and then you can fly around. And then the other one is, yeah, if all else fails, it does an RTL, but it doesn't do an RTL on land. It RTLs loiters above home, and then if you take control of the sticks again, it'll allow you to go back into Acro and fly off. Because what you don't want to do is it just keep landing and having to take off the whole time. But yeah, generally, if things go wrong, RTL is my friend, and yeah, handle things that way.
Fantastic. That was an incredibly slick set of demos, Andy. That's brilliant. Thank you. Another round of applause, please.
Thank you.
Wherever's good for you. I'm happy forever.
Okay. Demo for his
Thanks, Matt. All right, so I'm going to show two demos today. One is the flips on the switch, and I'm going to do that first because I'm pretty sure I won't crash the vehicle. And then the second one, I will do the acro fencing in loiter, and if that goes well and we've got enough time, maybe I'll try it in acro. We'll see. So just a little bit about this demo. So the sort of the approximation that I've made with help from Leonard and others is that when the drone is in a stable hover, it's got 1 G of thrust. And so there's a configuration parameter that says how many Gs of thrust you want to apply to get that initial burn. And basically it multiplies the throttle at that hover to get that thrust. I can't use the actual hover throttle that's learned because it's too high. That sort of bottoms out at 0.125 and this hovers at 0.09. So I have to configure that as well. So this is configured for 2 Gs of thrust. And I'll do 1 flip, 2 flips, see how 3 flips go, and then take it from there. All right.
All right. So one of the problems with this is that EF seems to get very, very upset between flips. And so there's sort of a time limit on how much swing to accept before it's finished. I'm going to take it out a little bit. Go up a little bit. Okay. So this hopefully is 1 flip. I'm just going to press the switch once. All right. And then it should navigate back to the starting position. I might actually read what my error message says. Okay, so we'll start a little bit again. 2 flips. And then, so one of the things it's doing is the flip itself is rate only, so we're applying a rate and sort of calculating how long you need to apply that rate for to get the number of rotations. And then when it detects that it's passed the 180-degree point on the final flip, it returns to attitude mode, and that's the one that brings it in for this very abrupt final thing. All right, 3. Do I dare fall before I switch to the other demo? Yeah. All right. Good call. And at that point, the ETF is very upset, so I'm going to bring it back, put a new battery in, and try a little demo. So I have to reconfigure this so the sprung-loaded switch I'm using is using my e-stop switch. So I have to switch those over. But for the other demo, I definitely want e-stop somewhere where I'm familiar with, so I'm just going to reconfigure the boxer. All right, am I back on? All right, so this time I'm going to do the Acro-Fencing code. So I've set up a poly fence all the way around the field with a flip for the houses at the end. It's approximately where the fence is, and then the margin fence is set 40 meters in, which is kind of at the end, just beyond the end of the landing pad. So what I'm going to have to do is walk out beyond the margin so I can take off, otherwise it just kind of spams me the whole time. What I'll do is I'll fly, well, I'll take off. You'll see it does the auto take off. I'll then fly towards this boundary over here, and hopefully it should flip me around, put me back into the field, and we'll do that a few times. Can you see, is the video coming out on the screen? So you should be able to see what I see in the FPV goggles. Sorry? And at this point, I might lose the mic just to not tempt the demo gods.
Yeah, I'll probably need a spotter. Yeah. Do you want to be a spotter? Right.
I think it's off now.
Just trappy. I can't see.
Don't worry. Don't worry.
All right. Okay. Carry anything I can. You can. Good. Sorry? I'm going to move the copter out. So I'm just going to move the copter out beyond the fence.
Helicopter in the distance.
Randy, you see the copter, right?
Yep.
Yeah, you see it. It looks like it's heading south, so.
It comes towards you, I would scatter.
Everybody wants you to know there's a copter.
Sorry?
The copter. Yeah. It's
okay.
heading south. I think it's not coming any closer.
It's all right.
You're gonna sit here?
No, I was just going to say something. Do you want to? Can you just pass me the mic?
Yep.
Sorry.
Yes. Okay, so I'm in loiter, which you can see. I'm going. Yeah. Right, checking e-stop works. Right, I think we're good to go. So I'm going to enable Acro-Fence, which should be this one. And then I also have kill scripting on a switch in case things go horribly wrong. So no safety in this place. Friday. It's going to be inside now. just breached and everyone else was conscious?
Well, I think it actually breached this way. It allowed for it to come on. It was my fault.
I took it too close to us, so you breached the direction. I should have known better. It's landing where it took off from, which is the right thing to do.
Thank you.
No final words, right?
Huh?
No final words, right?
I would just say finally, you could see there was an EKF lane switch at the end there, and the EKF was very, very unhappy as it came in, and that was why we were sort of getting it going around like that. So this is slightly the problem with this is you've got to have a very good GPS, you've got a very good compass. The EKF has got to be very, very happy, and even then, it feels a bit like you're sailing quite close to the wind. But you know, I've shown it can be done. So more hacking to do, but I'm quite pleased with that result.